Welcome back. Now we're going to talk about some disk imaging techniques which are available for use. We're going to cover DD, DC3DD, and FTK Imager. There are other ones out there. These three are some of the more common and depending upon the purpose may have different popularity associated with it. So just to talk about forensics imaging really quickly, it's a block by block or bit by bit duplicate of some sort of storage. So when you have a storage device, it's going to be stored on the hard disk or on an SSD or a USB stick, and you want to get an exact replicate or replica of that storage into a image file. And in order to do that, you need to capture every single sector, including unallocated space, deleted files, metadata, while not modifying the original device. So this is different from a normal file copy. A normal file copy is going through the operating system, accessing the file, and then it has an API call which will take that file and then duplicate it on a new location. That can change the metadata of the file if not done in a method using a write blocker. The file system, anytime that it will copy a file, could update an accessed timestamp. It might change some of the contents of the file. It depends upon what you're actually doing. The other thing that file copy will not do is it will not copy everything on a file. It may leave some stuff behind. So a forensics image copy is literally a block by block copy of the particular storage. And it's really important with this to copy the unallocated data and deleted data, because if you need to run a forensics image or an analysis on that, then having that deleted data may allow you to retrieve and recreate certain information that had been lost. You need to have a write blocker, and we'll talk a bit more about what a write blocker is a little bit later, but it comes in a hardware or a software variations, and it's really a method to prevent any writes from occurring on the actual device. It allows the operating system to read the data, but not write any data to that particular device. You also need it to be hash verified, and we'll talk about hashes a little bit later in more depth, but hash just guarantees, or it doesn't guarantee, but it shows that data has not changed from beginning to end. Specifically, you take a hash of the drive, you image it, and then you take a hash of the image, and if those hashes match, then it is an exact block by block duplicate of the original device. So there are some different formats for this. You can have a raw format, and this is pretty universal and standard. It's literally a block by block copy. There's a tool out there called DD that we will talk about, which does raw image formats. Any raw format can be read by any other software operating system. There's nothing which is tying it to a specific vendor. It's a single file. There are ways that you can split it up, and different utilities will let you create a split raw file in different methods, but typically it's just a single file or a single image. Nothing's proprietary. There is no compression with that. So if you have a 1 terabyte drive, you get a 1 terabyte image. If you have a 10 terabyte drive, you get a 10 terabyte image. So compression would allow it to shrink the overall size of the image without losing any information. And the raw format typically doesn't have any compression. There's also no embedded metadata typically, or any sort of case notes or anything. Generally what you would do is, if you do have a raw image, there would be a corresponding file which would list the metadata, the case notes, the hashes, and everything else which is relevant to that particular raw image. And that way, if someone took that raw image and they had the corresponding metadata in a file, then they could use that to verify the integrity of the particular image and that the hashes match. There's also no internal hash verification. So when you run the command, there's nothing built into raw images which stores the hash. Or when you're loading the particular image, there's nothing which will verify that the hash has not been changed or the data hasn't been changed. So there's nothing built into it. You can always write your own scripts and things which will accomplish that, but it's just not part of the raw image format. The next one is going to be the E01 or expert witness format. And this one is older, but it's very well established. It's used quite a bit. This is what FTK Imager uses by default. This adds in compression so that a image can be reduced by 2-4 times the original size. It will also embed metadata, notes, all sorts of other information into the actual file format. So once you have an E01, and you may have E01, E02, so on and so forth, because you can get it split multiple times. But once you have that all in a directory, then it can be loaded. It will automatically have all of those particular case notes and everything else as part of it. It has built-in MD5 and SHA-1 hash verification, and it's been widely accepted worldwide as a good standard for data retention for digital forensics. Unfortunately, it is a proprietary format, but it is widely used and a lot of people rely on it, but it is a closed source format maintained by a specific company. And it requires compatible tools to open and process them, which there are a lot of tools out there which will do this, but it does kind of violate the spirit of open source and universal access. The last one is going to be AFF4 or Advanced Forensic. This one is much more modern than E01. It has better compression. It's an open standard. It's developed, I believe, by Magnet Axiom. And it is a open standard that anyone can use. There's a GitHub repo which has repositories on implementations in Python and other languages. And so it's not tied to a specific vendor. It uses SHA-256, which is much, much better than MD5 and SHA-1. And it can scale to terabyte images as opposed to much smaller images. And it still has generally better compression than E01 would have. It does also support logical drives and logical imaging, as well as physical drives and physical imaging. There are less universal tool support than E01, but it's mainly because it's a newer type of format. And if you have any sort of legal cases or anything that you're working on, courts may question a little bit more about the process and what it is. There's a lot of documentation on what the standard is, but just be aware that since it is not as universally accepted as E01, there may be additional questions that would have to be answered as to how it works and why it is as secure as other ones. So, talking about some of the tools. DD, Disk Duplicator, also known as data destroyer or disk destroyer, because if you are not careful and you run the command wrong, it can destroy data and it will destroy drives, and it will not prompt to make sure that you know what you're doing. It assumes that a user knows what they're doing when they're running that command. So the command, it's DD, and then the IF is your input file or your in file. Your OF is going to be your output file. So in this particular example, it's reading from a device, SDB, and it's writing out to an image file. The BS stands for a block size, and that is a 4 kilobyte block size, which is pretty standard, and it is the way that a lot of disk duplication tends to happen. It's the best for optimal performance. The CONV flag is for the conversions, and so it will not stop on errors. and it will continue on bad sectors, and it will fill it with zeros. And so that's effectively what it does. There is another option, and so if you want to do the same thing with monitoring, there is a separate command called PV, which is pipe viewer. And effectively what you do, and the lines in between each of those commands is what's known as a pipe. So it's going to be the shift backslash key. And so you're running the DD command. The output from that, you're passing into pipe viewer, and then you pass from pipe viewer into your output file. So notice that the left-hand side removes the OF part of DD, and the right-hand side only has the OF. So it's in Linux, what you really have is this pipe ID where you're passing information from command to command. And so what PV will do is it will actually have a visual display showing the progress that it's going through, the amount of data that's been transferred, the speed of the data, and everything else. Old versions of DD did not support any sort of status as it's working. Newer versions do have a separate flag, status equals progress, which is built into DD and will show you the actual status of what it's doing. So you can use either method, but it does make it a little bit easier to see the status to ensure that data is actually transferring, and you can see the speed of the particular transfer. There's been times where I forgot to put the block size and the transfer rate was really slow, like 3 megabytes a second. Adding in the block size, the rate jumps up to 20, 30 megabytes a second for the actual transfer. So process monitoring or progress monitoring, or the status equals progress, is just going to ensure that things are working and it's not stuck doing something that it isn't going to finish. The other part is you can verify the source and the image. And so what you do is md5sum is a command in Linux, and that will take some file or some device, or you can even prompt it from standard input and generate the md5sum. So this particular command, it's running md5sum on the device. So it has to scan through the entire device, calculate the MD5 hash for that, and then the greater than tells it to redirect the output to a file. So this is calculating the hash and then storing it in the file pre.md5. The double ampersand is that logical AND. So if that first command succeeds, then it goes on to the second command. And the second command is calculating the MD5 from the image file. So you'll run this as a multi-step process. Your first step is doing the image, either with Pipe Viewer or some other method. Then your second step is calculating the MD5 of the device and the MD5 of the image. And then that last part of the command is running diff. And what diff does is it takes two inputs and it checks to see if they are exactly the same or if they differ. And so you have pre.md5 and post.md5, which are the calculated MD5 hashes for the disk and the image. And if they are exactly the same, then diff doesn't return anything. If they differ by even one character, then it will print out where the difference lies on which line and that sort of stuff. So this is a way to manually calculate the hashes and then compare the hashes to ensure that nothing has been changed. So again, to reiterate with DD, there's no error logging. It could just fail. If you don't have a proper write blocker in place, then it could cause data to get changed or adjusted, because DD is not going to protect the user on making sure that you use the right command the right way. And you also need to hash independently, so it doesn't have a built-in hashing mechanism. On the flip side is a command DC3DD. This is a newer fork of DD that some developers, they took DD, they took the source code, and then they added in a lot of stuff to do forensics imaging. So There's built-in hashing. There's ways to wipe devices. There's ways to split a image into multiple other images or a device into multiple other images. So it has built-in MD5, SHA-1, SHA-256, SHA-512. There's probably other built-in hashing algorithms. I'd have to look at the documentation and see what is actually included with that, but it is part of the actual command. So you can see that the command DC3DD, very similar to the DD command where you have your input file, but there also is an HOF for your output file, and you can add in a hash flag to specify which particular hash version you wanted to use. There's also a log flag, which will allow you to write out the hashes, the information and everything to a log file so that you don't have to do it as a separate step. Has a built-in progress indicator, so it doesn't require the status equals progress or the pipe viewer for seeing what's going on. There is error logging, which was built in. And so if you have a log file, as you're doing it, it'll log all of the bad sectors to that log file and help keep track of all that. There is a separate verification pass. So once it does an image, it'll actually go through that image and compute the hashes, compute everything, compare it to ensure that nothing has changed in its entire progress. If you wanted to split the output, then there is that OFSZ 2G to split it into 2 gigabyte files for that particular image. So DC3DD doesn't necessarily always come pre-installed on systems. I believe Kali, you have to install it manually. I'd have to double check and see. But once it's installed, it will work pretty similar to DD. There's a little bit of differences in some of the ways that you do things, but it will allow you to more easily create forensic images without having to do a multi-step process as part of it. The other one is going to be FTK Imager, and this is kind of the industry standard. It's a GUI or graphical user interface imaging tool, widely accepted in legal proceedings. It is Windows and I believe Mac. I'm not sure if there's a Linux build. I'd have to double check and see. But there is a community-free version out there. It does ask for registration when you go to download it, but you can honestly enter whatever information you want, and it will still give you a download link. It will allow you to create an E01 or a raw image or AFF, smart images. Like I said, generally E01 is what has been used historically for the longest time. A lot of people are starting to switch over to the AFF4 image format, but it's newer and so it doesn't have as much support behind it. But the openness of AFF4 is much more desirable in my opinion. It does embed the metadata, the case information, the hashes, all of that as part of the format. So when you create an image, it has that metadata at the beginning of the image, and then it stores the actual image after that metadata. So it's part of the case, it's part of that. It doesn't modify the actual information, and so it's able to keep all of that together into one or sometimes split files, depending upon how it's distributed. It does automatically calculate MD5 and SHA-1. My understanding, and I'd have to go back and check, is that it doesn't calculate SHA-512 or any other hashing algorithms. It just does MD5 and SHA-1. It also allows you to look at the file system contents without actually mounting it. So one of the things that the other imaging tools would do is you would create an image and then you would have to go through a separate mount process to actually see the data on that image. Or you might have to load it into another tool to start analyzing it. With FTK Imager, it's all part of the same software program to where you can start browsing the file system and running some analysis on it without having to go through a multi-step process to load it. So it's pretty nice that way. just kind of comparing all of these tools. DD is primarily Linux, Mac. DC3DD is a fork of DD. I don't believe that there is a Mac build of that, but there may be. But you can use those. The court acceptance is accepted, but there may be some questions on the exact process. This is where it comes down to documentation. The more clear the documentation is, the fewer questions that would arise as to the appropriate use of those tools. When in doubt, contact a lawyer and make sure that a lawyer says this should be sufficient for the particular court case or not, or use the industry standardized and widely accepted tools. So like FTK Imager, Magnet Axiom. Really, Haynes? So when in doubt, probably just use FTK Imager or Magnet Axiom or Cellebrite, as those are industry tools. They've been widely accepted. They produce verifiable output, and other forensics imagers know about those and know how to use the tools and will know if things were done in a proper method. So takeaways: forensics image is going to be that bit-by-bit copy of every sector. It's not a file copy, it's a low-level, block-by-block copy of the information, including any allocated or unallocated space or deleted data. DD is universal, doesn't have that built-in verification. Need to pair it with other hashing commands like MD5 sum, there's SHA-256 sum, so on and so forth. DC3DD adds that hashing and logging, but again, as they are not true forensics tools, then there would be additional documentation which would have to go in for those particular uses. FTK Imager creates the E01 images with the embedded metadata, hash verification, that sort of stuff. Like I said, there is Magnet Axiom. There are other tools which will generate the AFF4 format. Those are newer and may or may not be supported as much. You want to make sure you use it with a write blocker because you don't want any changes to the original image. And pre and post acquisition hashes have to be documented, must match before any analysis can proceed. Thank you very much.